Hi there, this is a new video about the false position method for continuous function. So as we always do, let's start with a new function, f of x equal to 46 x cubed plus 3x plus 1 equal to 0. So this is actually going to be my new function. I'm going to choose 2 points, x1 and x2, that once I plug them into the function are going to give me a positive value and a negative value. My x of 1 is going to be negative 4, and my x of 2 is going to be 1. So if I plug them back into my function, I'm going to get f of, negative 4, which is going to give me 46 times negative 4 cubed plus 3 times negative 4 plus 1. It's going to give me 46 times negative 64 minus 12 plus 1. It's going to give me negative 2944 minus 12 plus 1. So negative 2955. And then f of 1 is actually going to give me 46 plus times 1 cube plus 3.1 plus 1, 3 times 1, 3 times 1 plus 1. Okay, so basically 46 times 1 plus 3 plus 1, so 46 plus 3 plus 1, so 50. There we go. So basically I got two values. The very first one is negative, the second one is positive. And I gotta say that I choose a very bad function because the once I do the sketch, the sketch is gonna be terribly out of scale. I'm gonna try to make it in scale, but it's gonna be terribly. I'm gonna make it very long, but I'm pretty sure it's gonna be terribly out of scale. Anyway, I'm gonna try to do my best, but alright, so x and y. So this is 0, and my very first value is x of 1, so this is negative 4. So x of 1 is negative 4, so like let's do it here, negative 4. And x of 2 is going to be 1, so we're going to do it here, 1. So we know that at negative 4, the value is negative 2955, so I'm going to write it like here, negative 2955. It's going to be here. Yeah, it's terribly out of scale anyway, but whatever. And at 1 is going to be 50, so I'm going to put it here, 50. Alright, so we kind of expect the function to be like this, like crossing somewhere between negative 4 and 1, and crossing within this interval, because, you know, if the function is continuous, there must be a point in which it's going to cross the axis, which means that it's going to be 0. And we're looking for that point. So, as I always do, I'm going to rewrite the formula. So, for the false position method, we have xr equal to x2 times f of x1 minus x1 times f of x2, everything over f of x1 minus f of x2. So, as I always say, what this formula really says is that once we get xr1 is going to be given by x2, so basically 1 times f of x1 So negative 2,955 minus x1, so negative 4, times f of x2, so 50. Everything over f of x1 minus f of x2. So f of x1, negative 2,955 minus f of x2, so 50. And if we compute this, we get 9 minus negative, well, negative 2,955 minus minus 200 over negative 3,005, which is negative 2,955 plus 200 over negative 3,005, which gives me negative 2,755 over negative 3,005, which is 0.91. Okay, so 0.91, that's gonna be my new point. So 0.91 is roughly here. It's gonna be an auto scale anyway, so doesn't matter. And now I'm gonna plug back 0.91 into my function and see whether I get a negative or a positive value. So f of 0.91 is actually gonna give me 46 times 0.91 cubed plus 3 times 0.91 plus 1. So this actually gives me 46 times 0.75 plus 2.73. So I get 34.5 plus 2.73, which gives me 37.23. So it's a positive value, which is roughly, well, 37, like here, 37.23, right here. There we go. So since it's a positive value, we don't have to expect the function to cross the axis between 0.91 and 1, but we expect it to cross it between negative 4 and 0.91. So those two are going to be our new starting point, x1 and x2. So let's do this. xr2 is going to be given by x2, so 0.91 times f of x1, so negative 2,955 there we go, minus x1, which is negative 4, times f of x2, so 37.23. Everything over f of x1 minus f of x2. So f of x1, negative 2,955, minus f of x2, so 37.23. So if we compute this, we get a negative 2,689.05 minus negative 148.92 over negative 2,992.23, which is like, well, negative 2,689.05 2089.05 plus 148.92 over negative 2992.23, which is gonna give me negative 2540.13 over negative 2992.23, which is like saying 2540.13 over 2992.23, which is roughly 0.85. All right, so now that we have found our new point, 0.85, which is like here, 0.85, we're gonna plug it back into our function and see whether we get a positive or negative value. So there we go. F of 0.85. I'm gonna plug it back in here, and we're gonna get 46 times 0.85 cubed plus 3 times 0.85 plus 1 is going to give me 46 times 0.61 plus 2.55 plus 1, which is going to give me 28.06 plus 2.55 plus 1, which is 31.61. So it's still a positive value, so 31.61 will be here. 31.61 will be here. There we go. So we could be going on and on and on again, and we will be find, you know, a closer approximation for this curve, and we're gonna get closer and closer to 0. But you know, I'm not gonna go over and do XR3. So our approximation will be, our best approximation for this curve will be something like this. Something like this. It goes like up this way. So this is going to be our best approximation for this curve. And as you can basically see, we will be, since the value that we have found is positive, we will be going on and use -4 as our x1 and 0.85 as our x2, find a new point, plug it back into our function and get, I don't know, like here, then do it again and get here, do it again and get here, do it again and get here. Eventually we're gonna find a point somewhere like between here, probably, which is really close to 0. If it's not 0, we can be lucky and find 0 anyway. Never happens, by the way, never. So, but you know, if you're extremely lucky, you can. And generally, you can do many iterations, get closer and closer to 0. All right, so this is the end of this other example, and I'm gonna make one more example about this method. Probably a few more, I don't know, it depends. It's kind of fun to draw the graph and do this, so I might make a few more examples here. All right, so this is it from now for these examples, so stay tuned for the next one. Cheers, bye.